Let's talk about the quantum frontier. We're going to dive into the invisible science that's already reshaping our world and, believe it or not, holds the key to our entire future.
So let me start with a pretty wild question. What if the most powerful forces shaping everything, our technology, our world, maybe even reality itself, are things you literally cannot see? Well, that's both the promise and the deep mystery of the quantum world.
All right, so to really get a handle on where all of this is headed, we first need to understand the basics of this invisible revolution. At its heart, quantum physics is basically the rulebook for how the universe works at the tiniest, most fundamental scale. We're not talking about things like planets or even grains of sand here. We're going way, way smaller, down to the level of atoms, the electrons zipping around them, and even energy itself.
Now the key clue is right there in the name, quantum. It just means the smallest possible unit of something. So think of it this way. Energy in our big world seems smooth, right? Like turning a dimmer switch on a light. But in the quantum world, it's more like a light switch. It's on or it's off. It comes in these tiny individual packets called quanta.
But this idea of energy coming in little packets, that's just the beginning. From here on out, things get really, really weird. I mean, the quantum world just doesn't play by the rules we're all used to.
Okay, so we've got the whole quanta thing down. Now we're going to tackle two other concepts that sound like they're straight out of science fiction: superposition and entanglement. These are the ideas that unlock all the incredible stuff we're about to talk about.
First up, superposition. And you might want to buckle up for this one. You see, in our world, a thing can only be in one place at one time, right? Obvious. But in the quantum realm, a particle can be in many places or in many different states, all at the exact same time. It's not here or there. It's here and there, simultaneously. It's a total mind-bender.
So why does this weirdness matter? Well, this one concept completely flips computing on its head. A normal computer bit is super simple. It's either a 0 or a 1. That's it. But a quantum bit, or a qubit, uses superposition to be both a 0 and a 1 at the very same time. And that ability just exponentially explodes its potential processing power.
And just when you thought it couldn't get any stranger, there's entanglement. Imagine you have two particles that are linked in this deep, mysterious way. If you measure one of them, you instantly know the state of the other one, even if it's on the opposite side of the galaxy. It's like they have this invisible connection that breaks the laws of space and time as we know them.
Now, this isn't some brand new sci-fi idea. This stuff has actually been around for over a century. Way back in the early 1900s, geniuses like Albert Einstein started wrestling with these quantum puzzles. Then, over the decades, the theories were tested and proven again and again. And today, quantum science is one of the most important fields in all of physics.
It is so mind-bending that even Einstein himself was totally baffled by entanglement. He famously called it spooky action at a distance. So, hey, if you find it a little strange, you're in some pretty good company.
For a long time, all this spooky action was just a scientific curiosity. But here's the thing. Scientists didn't just prove it was real. They figured out how to use it. This strange, invisible world isn't just in a lab anymore. It's already in your pocket.
Seriously, the rules of quantum mechanics are the bedrock for so much of our modern tech. The transistors that power your smartphone and your computer, the focus beam of light from a laser, the incredible detail you see in an MRI scan, all of those technologies only exist because we figured out how to understand and control the quantum world.
So we've kind of mastered that first wave of quantum tech. But of course, that just begs the question, what comes next?
This next step is what everyone is working on right now. It's about moving beyond just using the effects of quantum mechanics and starting to harness its weirdest features, like superposition and entanglement, directly. This is the Quantum Revolution 2.0.
And this leads us to the big one, quantum computing. By using those qubits we talked about, these machines could solve problems that are literally impossible for even the world's best supercomputers. Imagine being able to accurately simulate our entire planet's climate, or discovering life-saving drugs in a matter of weeks, not decades. This is the kind of power we're talking about.
And it's not just about crunching numbers. Remember that spooky action of entanglement? Well, you can use it to create communication networks that are, theoretically, 100% unhackable. If anyone tries to listen in, the link is instantly broken, and you know you have an intruder. It's the ultimate in secure communication.
Okay, but with any technology this powerful, this world-changing, you know there's a flip side. This incredible power comes with a whole lot of responsibility.
On the one hand, the promise is almost utopian. You can just picture it, right? A future with new, clean energy sources, healthcare totally transformed by perfect biological simulations, an AI that helps us solve humanity's greatest challenges. But on the other hand, we have to face the challenges head-on. A computer that can break every form of modern encryption, that's a huge security risk. The rise of superintelligent AI brings up massive ethical questions. And maybe the biggest question of all, who gets to control these incredibly powerful systems?
It's pretty wild when you think about it. What started as a simple quest to understand the tiniest, invisible bits of our universe has now unleashed a technology that's going to define our future. The quantum world has been here all along, and it's about to become very, very visible.
And that brings us to the final question I want to leave you with. When you look at the unbelievable promise, and then you look at the very real challenges, what do you think? Are we standing on the edge of a total transformation of our world, or is it just too early to tell for sure?